Okay, number 4 here. The last thing we have to figure out are the sums of squares, what's called error. Error in this case is just what it was before. It's the sums of squares within group. So the source is within group, sums of squares, degrees of freedom, variance, whatever you want to call it. So we have to figure this out. And I didn't compute that for you because I want to make sure you understand the key concept here. What you basically have to do is go back to each one of these 4 cells and figure out the sums of squares within groups, and then add all 4 up. So let's figure out the sums of squares within group 1, no alcohol, no Xanax. What are the sums of squares within that group? 100, 100, 100. Well, if you have 3 of the same numbers and sums of squares is measuring dispersion, you should have a sums of squares of 0, because 100 minus 100 is always 0. So the sums of squares in the no Xanax, no alcohol group is 0. Let's move now to the 72 ounces of alcohol, no Xanax group. 78, 80, and 82. Could you figure out the sums of squares for that group? 78, 80, and 82? What's the mean of the group? 80. 78 minus 80 squared plus 80 minus 80 squared plus 82 minus 80 squared. That should give you a value of what? 8. So you have a sums of squares within that group of 8. Why don't we go down? 10 milligrams of Xanax and 72 ounces of alcohol. 18, 20, and 22. Hopefully you can figure out that the sums of squares within that group is also 8, because it's still measuring the same spread, 2 points apiece. 18 minus 20 squared, 20 minus 20 squared, 22 minus 20 squared. Sums of squares 8. And then you got the last cell, 76, 80, and 84. Tried to make the numbers easy for you there. 76 minus 80 is 4, squared is 16. And 84 minus 80 is also 4, squared is 16. So the sums of squares within that group is 32. So if you write the numbers in there, 0, 8, 8, and 32, what is your sums of squares for the error? Hopefully you figure it out that 0 plus 8 plus 8 plus 32 is 48. So in the summary table, write sums of squares error at 48. Now let's go for the next column in the ANOVA summary table. Let's actually start with the sums of squares error within group. How many degrees of freedom do you think we have there? Well, how many degrees of freedom in the no Xanax, no alcohol group? You have 3 people in there. 2. How about in the 72 ounces no Xanax? 2, 2, and 2. So your degrees of freedom within group are 8. What is your variance within group then? Or your mean square within group? That should be a value of 48 over 8 is 6. So your variance within group, pretty small at 6. Now let's figure out the other variances. So the sums of squares for the alcohol main effect was 4800. That reflects the fact that the 90 is quite different than the 50. How many degrees of freedom do we have for alcohol? Well, how many levels do we have of alcohol? 2, so we have 1 degree of freedom. So the variance for alcohol, or the mean square, is 4800. How about pills? How many levels of pills? 1 as well. So if there's 1 degree of freedom there, 4800 over 1, mean square is 4800. How about alcohol by pills? Well, to get that degree of freedom, you multiply the other 2. So if alcohol was 1 and pills is 1, alcohol by pills is also 1. So 1200 over 1 degree of freedom, the variance for the interaction, remember, don't use the term main effect, the variance for the interaction is 1200 for that as well. So those are your mean squares, 4800, 4800, 12, and then for the mean square within group, 6. Now we need F ratios. How do you get F ratios? How many are we looking for? We're looking for 3. Is there a statistically significant main effect of alcohol? How do you figure that out? Well, you get the variance due to alcohol, which is what? 4800, and you divide it by the variance within groups. So 4800 over 6 is going to be what? 800. How about for the main effect of pills? Same thing, right? 4800 over 6, because the within treatment variance is the denominator. 800 again for the F ratio. How about for the interaction? Well, 1200 over 6. 1200 over 6, the F ratio for that is 200. Now look at all the probabilities over there. It says 0, 0, 0. You didn't even actually have to do this. That actually tells you what? That everything is significant. So there are a few ways to write this out. If you actually got this on the table, then you could write not 0, 0, 0, but p less than 0.01. So I'm going to stop this one at this point and keep going then.